Hello 108 students, Mr. McHugh here, back with you. We are going to keep working on section 9.5 on this video, and we are tackling page 6. And this first part of it here is a summary, and I kind of promised you some graphs here from the last video and the last page. And we are talking about quadratic equations that are in the form f of x, or you could say y. It doesn't matter which way you go. Book likes f of x. And you've got x minus h is a constant squared plus k, and you guys all know the k is your vertical shift, and you keep the number whatever it is, that's how many you go up or down. H, you take the opposite sign. Okay, we've talked that to death, so that's the shortcut way to remember them. You've heard me explain why it's that way. So I just want to show here a little bit here of the parent graph. Here I have in blue y equals x squared. I graphed it here, and then I took example 3, which was x plus 3 quantity squared minus 2, and I did that on the whiteboard video number 20, by the way. At least yeah, number 20. And so you could be whiteboard number 20, you could review that. But here was the graph, and here's the key thing: you got to get that vertex. So what did we do? We took the I like to use v sometimes, vertex, and then that would be plus 3, change the sign to negative 3 for h is horizontal, and the y vertical movement is whatever the k number is up here, so it's a minus 2, and so negative 3 minus 2 was my vertex. And then I went through and picked a couple points. Now let me show you a little tip here. You know these are parent graphs right now because, and we're going to talk about this in objective 3 here, but here's the tip. In front of that parentheses is a coefficient of 1. Okay, just like y equals x squared is the parent, the coefficient, the a term was a 1. If it's a 1, then you have a parent graph, no matter what shape it looks like. Thus, here's a little shortcut. You could go over 1, up 1, back 1, up 1 to get your 2 points. If you go back and study y equals x squared, you'll see that's the pattern. You can go back 2 units and up 4. 1, 2, 3, 4. Go forward 2 units and up 4. 1, 2, 3, 4. Okay, that's a fast way to manually do it. That's an old school technique here. So, and there you go, you would graph that. Now I explained on whiteboard video number 21 how to use MyMathLab real quick. You use that button that looks like on a palette. It's got a parabola, it's got the vertex that's got a second dot. Snap the vertex down, you see the parabola start to move. Follow your mouse, snap down your second point, and it'll mirror it because parabolas are symmetric. Okay, and what I wanted to do here was I picked example 3b in green mode here. Y equals x plus 3 quantity squared plus 2. What would that vertex be? Let me go to green mode here. This vertex would be what? Opposite in the horizontal, so it's negative 3. No, I wanted this to be a minus. I apologize. This is a minus 3. I apologize about that. And then plus 2 on the vertical. So that causes you to go plus 3 up 2. Okay, so it's one of the examples. It might not be 3b. I'm not sure which one it is now, but you'll go back and look at it. Okay, so I just want you to see the difference here between where you move the vertex. And sorry, my parabola is ole moly. Not very round looking, but you get the idea. They are the parent. Up, back 1, up 1, back 1, up 1, up 2, up 4, back 2, back 4. That's a quick way to get them, like I said before. Okay, so let's keep going here. Now, we're building up this case here. We are now going to go ahead and tackle objective 3. Predict the shape and the direction by looking at the coefficient of the x squared term, the a. Okay, and I gave you a little bit of hint up here in the previous examples. A was equal to 1, and we didn't have to worry about it. And it was a positive 1, and that's why all the graphs were opening up. Okay, and so a couple summaries you can make here. You can get used to this form. A is the coefficient in front of the x squared associated with the x squared. Okay, and then it's parentheses x minus h. Here's the horizontal movement. There's the vertical movement like we've been discussing. The vertex is always h comma k. Remember, you bring the opposite down, and then you bring down whatever the constant is on the outside. Once you know that line of symmetry, that vertical line of symmetry that I've been showing you, if I ask you for the vertical line of symmetry for this problem here, it would be what? I'll try to draw it here. Now, you draw vertical lines, they're always x equals y. Remember how we used to graph in chapter 3? Vertical axis, what axis do you cross? X, where? -3, and that's why that's the vertical line of symmetry. Okay, x equals h. And then this is interesting. We're going to study this more here. It says if the a coefficient is positive, then the parabola opens up, and we've been doing that. If it's down, if it's a negative, like a negative y equal negative x squared, what would happen to that graph? Well, we're going to show that down here, right down here. I'll get to it. And then you're going to find out here after a couple examples that if a is a negative number, it opens down. The parabola opens down. The vertex is the max. And up here regularly what we've been looking at, the vertex was the lowest one. So it's y equals a positive x squared, it opens up, and y equals a negative x squared, it opens down. Okay, and objective 3, we're going to cover this more on the next page here. So if the a coefficient, here's it says if the absolute, the book goes crazy, if the absolute value is less than 1, aka if it's a fraction, which is a small, it's going to be a wide graph. It's going to open up. If it's a number, I just up saying number, then it's going to be a skinny graph. It's going to open like this or like this. Okay, and you're going to see this on page 7. So real quick here, I use the example f of x equals -1x squared, or y equals -x squared. I wanted to do a couple expanded xy table points coming in here. There's the vertex at 0, 0. You can see the pairings here. And the key thing is, look at that. You put a -2 in. -2 squared is 4, but that minus on the outside switches the sign to a negative. Thus, it forces the graph to go down. Okay, now, I encourage everybody to study this, engage in this learning process. You're getting into a new level of mathematics, is what I tell my class students. It's not just memorizing things. It's not brute force anymore. Look and understand, why does that negative a bring it down? Okay, why is a positive bring it up? Okay, then you'll feel more comfortable. You know what you're dealing with. Okay, Mr. McHugh here. I'm going to check off here, and we'll say adios to page 6 class. We're working hard. I will see you for page 7. We will explain the a coefficient and the small number of fraction opening up wide, big numbers or a number greater than 1 opening up skinny. Okay, so till then, I will catch you then. Okay, bye.